Alright, y'all, this video series is going to walk you through the questions on the concept list just to make sure you understand where those numbers that I put out there for you actually are coming from. So question number 1 talked about limits. So you see a mixture of problems with infinite limits and limits approaching a single value. So we're going to talk about the infinite problems first, so that is 1 and 2. And in both of these cases, it's having x approach positive infinity, but it could be negative infinity as well. And this process is going to be similar for both. So what we want to do is check out the degree of the numerator and the degree of the denominator. As a reminder, that's just your highest exponent value you see. So on this first example, that highest power is 2, and on the bottom, highest power is 2 again, they match. So when they're matching, that's saying the numerator and the denominator are really increasing towards infinity at a similar rate. Okay, and when that works out, the easiest way to find the limit is just by dividing the leading coefficients of those terms dealing with those highest powers. So for us, that would mean dividing the 5, the coefficient of that part, and the 1, the coefficient of that part, giving you your limit of 5. Okay, really this is the horizontal asymptote that's happening on the graph, and that's why the limit exists. Looking at the next problem, similar process, we're going to look at the degree of the numerator. In this case, it is 1 being our highest power, and on the denominator is 2. So in this case, they don't match. Okay, so when they don't match, that means the numerator and the denominator are not acting at increasing the same rate. So in this case, the bottom is getting to infinity faster, and because of that, we're thinking about a fraction where the bottom number is larger. So we can think about it as like 1 over 2, and this is not equivalent to this particular function, but I want to show you why the limit's happening at 0. So the bottom's getting bigger faster, so 1 over 2, 1 over 10, 1 over 1,000. As we think about these values, they're getting smaller each time, specifically smaller towards 0. So when you see that power on the bottom bigger, it doesn't matter what the rest of the equation's doing in terms of what's added or subtracted to it. Your limit's always going to be 0. Okay, the one that we didn't see here is if we reverse that when the power is bigger on top. So I'm going to give you another example where we're looking at the limit towards infinity, but instead the x squared minus 1 is on the top, and we've got our 2 minus 7x on the bottom. So when this is bigger here, and as we're approaching infinity, the top part's getting bigger and bigger faster. So essentially your graph here, and in this case it has an oblique asymptote, but what's important is it's going off higher and higher towards infinity. So your limit doesn't exist, it's approaching infinity. Okay, so when they match, divide your leading coefficients. When they don't match, just find out where the bigger part is. If it's on bottom, it goes to 0. If it's on top, it goes off towards infinity or negative infinity. Looking at the next group here, we're approaching a single value, and usually what's going to happen with these problems that I give you, the value I'm asking you to approach will cause the function itself to be undefined. There's a point of discontinuity as you plug it in. Okay, so just to show you that example for this first one, if I were to substitute in negative 3 here and here, a negative 3 squared is 9, then we've got a negative 3 and a negative 6, that cancels out to 0, so we're dividing by 0. And in math, dividing by 0 is not allowed, which means direct substitution is not going to work for us to simplify this limit. We have to use an algebra technique. Okay, so a lot of times that just means factoring. So if we try to factor this top part, it's a difference of squares. If we want to figure out x squared, we know x times x will get us there. And with the difference of square, you just have to take the square root of that second number, which would be 3 for us. Positive and negative gets me to that negative 9 with no middle term. On the bottom, similar process, we need to get to x squared, so that's x times x. This time we need a negative 6, so we're still going to have one number positive and one number negative, but we have to, when we add those two factors of negative 6, we have to get to a positive 1. So the only way that's going to work is if our 3 is here and our 2 is here. Remember, you can always FOIL those back to check yourself to make sure you factored them correctly. Okay, but nice things happen, and those x plus 3 factors end up canceling. Now, when we use direct substitution, we've got negative 3 minus 3 on the top, And on the bottom, negative 3 minus 2, there's no dividing by 0 happening. And we get a negative 6 over a negative 5, which gives us a positive 6/5, or the 1.2 that you see on your answer sheet. The next one factors the same way. It's the same expression, but this time they wanted to use a positive 3. That was a problem that actually didn't cause problems. So I'm going to show you two ways to do this. So if we look at the positive 3 here, if we've got 3 minus 3, I'm going to write that out, 3 minus 3, and on the bottom, 3 minus 2, we get 0 on the top divided by 1. Okay, but I'm going to show you a direct substitution here as well. 3 squared minus 9 is 9 minus 9. And on the bottom, 3 squared is 9 plus 3 minus 6. So in this case, we have 12 minus 6, which is 6, but we still got 0 on the top. So both of these expressions had 0 on the top, and a lot of times we get into this habit of thinking we can't direct substitute, but in this case, you actually could have. There wasn't any problem with plugging in the 3 immediately from the expression as it was written, because 0 is okay to have on top of your fraction. It's just not okay on bottom. So a lot of times you'll see 0 over 0 or some number over 0. Those are bad examples. But 0 on top is just 0, and you're done. Last problem here is not something you can factor. We've got an absolute value. Okay, what I want you to do when you're thinking about this is just holistically look at this fraction. We've got x minus 4 over x minus 4. The only difference is you've got those absolute values on the bottom. But recall from your algebra skills, okay, and just basic arithmetic with numbers, when you see the same thing on top and bottom, that's a fraction that equals 1. Well, in the case of that absolute value, the only thing that changes is absolute value makes the expression positive, okay, or 0 no matter what. There's no negatives allowed. So what that does is when we're reducing this fraction, we could have 1, but we also could end up having negative 1 because you could have a negative up here and a positive 1 down here because of that absolute value. They don't have to actually be exactly the same on top and bottom. So what we're going to do is just to look at what they ask us for to figure out which of the answers it is. So if you look at this notation, we're approaching 4, and again, plugging in 4 directly gives us 0 over 0. That's bad news. Okay, but it's approaching 4 from the left. So we want to look at numbers lower than 4 as we substitute them in. So if you just pick like the number 3, 3 minus 4 gives you a negative value, and on the bottom, even though it's still a negative value, we're taking the absolute value, which ends up positive. So this expression over itself has to be the negative version of 1, and that's where your limit is coming from.